Hey everyone, how's it going? Fifth Tech Talk, is it? Yes, I think so. Really good to be back. We are sticking to our schedule, trying to get a chance to share some cool topics every other week. We will talk about that later, but I think and I hope we can actually move to a weekly cadence eventually. I will be sharing some links for folks watching us, and there will be probably many more of you in just a few minutes, but that's why I'm just waiting for sending the reminder. But yeah, would love to have more of those. And if you are interested in speaking, I will be sharing more details. So we are back again for wireless topics. I think we've been talking about this a couple times already. We've been talking about the new modem subsystem recently, and today we're going to talk about all things wireless and cellular again with people from Blues. So I'm going to put them on stage really soon. Quick reminder for people watching live. This is meant to be super interactive. So whether you are joining from YouTube or from LinkedIn, well, ask questions. Like whenever you have something that comes to mind, just ask questions. And even before we start, we have this sort of motto, which is to have everyone say hi in the chat and say where they're from. And I'm always surprised and shocked to see how many countries we have. I think that the time zone and the time we picked is pretty much the sweet spot. So what do we have today? Like, let's see in the comments. I think in the past we've had people from Mongolia, from Australia, Austria. So yeah, just say hi in the chat. And I'm Benjamin, I'm joining from France, by the way. So yeah, that's for the general announcements. And with that, let's just bring our guest from today on stage. So starting with Rob and adding Zach as well, and TJ. Hey guys, how's it going?
It's going great. Thanks for having us here.
Happy to be here.
Yeah. So you guys have like all the same background, it feels like. Like you're all traveling this week, aren't you?
Oh, you mean literally the same background? Yes, we are.
Yeah, like it looks like, it feels very much like hotel rooms, no?
It just so happened that the three of us are traveling for offsite team meetings, and we are stuck in our hotel rooms, and fingers crossed that our Wi-Fi holds up.
Yes, we know how that works. I mean, yeah, many of us. So yeah, tell us a bit about who you are, like starting with you, Rob.
Sure. Hi, so I'm Rob Lauer. I am Director of Developer Relations here at Blues. That means I am at least partially responsible for all of our fantastic documentation and tutorials and guides and some of the public webinars we do. Actually, I'm responsible for the bad parts. TJ is responsible for the good parts. So I'll hand it over to TJ.
Yeah, this is a nice transition. I'm TJ Van Tol. I work as a developer advocate, work on the same sort of stuff. I'm loving seeing all the locations from everybody. I'm usually from Michigan and the United States. We are all in Salt Lake City at the moment. So maybe I don't think my laptop will get it, but we got, it's just going to pull in the building. But we got a nice view of the mountains in the background also.
Say some of us have a nice view. I think I'm looking at a parking lot, so I got that side of the hotel. I'm from the Ozarks in Missouri in the United States, and I work on the firmware, the developer experience firmware at Blues. I've been here for a long time. I used to work under Rob and with TJ on DevX and DevRel stuff, and so I've migrated over, and today I'm going to show you guys a little bit of what we've been doing with our SDKs around Zephyr.
Awesome. So yeah, well, so Rob, I think you're going to be the first to start off. Someone in the comment said that hopefully the wireless guys don't get issues with the wireless.
Yeah,
so we'll see about that. But
yeah,
between the three of you, I'm hoping that we should be fine. So yes, and thanks to everyone who already said hi in the comments. Pretty nice to see new countries, I think. Argentina, I think, is the first, and some new names as well. So as a reminder also to folks, like especially if you're joining on YouTube, you should definitely subscribe to the channel, like the video. I think that's what people said typically, but that's actually super helpful if you do that. And yeah, with that, Rob, I'm going to put you on screen, and just maybe as a quick intro and as a sort of echo to what I was saying in the introduction, we certainly talk a lot about wireless and cellular and IoT when it comes to Zephyr, and I'm super excited that we have this topic again on the agenda for today. But obviously, Zephyr is so much more, right? Like it's like many people would take Zephyr and connect their solutions to the internet using low power cellular and whatnot. But there's certainly more to it. And again, like I would love to cover other topics that are not necessarily always related to IoT, cellular, etc. So I will, while you take it away, I will be sharing the link so that if folks want to propose future Zephyr Tech Talks, that's the link for you guys. And with that, Rob, please take it away.
Great. Yeah, thanks again for having us here. So this presentation, as the slide says, is on wireless IoT with Zephyr RTOS and Blues. First, I want to do some quick introductions, but you know what? We already took care of this. So let's just click through that slide. So who is Blues? What is this Blues thing? Well, if I can oversimplify what Blues is about, we do provide hardware and services that try and back up this message of making wireless connectivity easier for developers and more affordable for all. And a big part of what we are about is revealed through this phrase of wireless harmonization. You'll hear a lot about this from Blues going forward. Yes, it's kind of like a marketing thing. And so what does it really have to do with Zephyr and what we're all about here today? Well, you'll see it play out as we talk today, but this is really the idea of product builders being able to build future-proof solutions by choosing the right radio access technology to build their connected solution, right? Without making upfront commitments. So without painting themselves into a corner. So regardless of the RTOS, regardless of the connectivity option you want to use. And I'll explain what this really means in a minute here. So why is this important for Blues, or for all of us really? Well, for most modern IoT apps, choosing between cellular, Wi-Fi, LoRa, whatever, it's generally a decision you're forced to make upfront. And that may be because of incompatibilities between radios, between provisioning models, between deployments. So you end up programming specific to these technologies at the start, right? And at the end of the day, I'm guessing that most of us don't really care that much whether we're using LoRaWAN or cellular or Wi-Fi or satellite, right? We just want to get the dang thing connected. So that's where this idea of wireless harmonization comes into play. Because in this like magical harmonized world, choosing a radio access technology can be a deployment time decision instead of a development one. So with Blues, you can develop a solution, and when it comes time to deploy, you can then make the choice of cellular, Wi-Fi, or LoRa based on the specific needs in the actual destination you're deploying to, not what you've coded into your firmware. And this is keenly important to us because everything that we build is, first, it's host agnostic. So you can bring any modern MCU, any single board computer. You can use any language you want, any RTOS. If you want to start prototyping with Arduino or prototyping with Raspberry Pi and then deploy with Zephyr, that is totally cool with us. You are welcome to do that. We're also cloud agnostic. We want to help you get your data from your device to your cloud. So I don't care if that's an AWS or if it's an IoT platform like a data cake. Blues is here to help you get your data where it needs to go. All to say, there's a reason we're here today, and that is that we do love being part of the Zephyr project. And tactically, we make this happen through our note-zephyr SDK, which Zach and TJ are going to talk about in a bit. But since I don't know how familiar any of you are with Blues nor your technical backgrounds, I did want to give a high-level overview of how we make everything happen from more of a developer's or a builder's perspective. And I want to start with the note card. So this one in particular is a dual cellular and Wi-Fi IoT device. The cellular side does come prepaid with 500 megabytes of data, 10 years of global service. It's all baked into the cost of the device. There's no subscription fees. There's no monthly SIM or data fees. But it's really only half the story when you're talking about Blues. The other half is our cloud service that we call Node Hub. And the two work together to form what we call a device-to-cloud data pump. So what does that mean? Well, in practice, what it means is developers buy a starter kit from us. They're going to hook up a sensor to it, start reading data with their host MCU, and deliver that data securely over cellular to Node Hub. And Node Hub will route that data automatically to their cloud, whatever it may be. So to be clear, Node Hub is a cloud service, but we aren't trying to create a platform that locks you in here, right? We exist to help you connect to your platform. again, if it's a big cloud or an IoT platform, that's all good with us. We're trying to solve that really messy middle piece of connectivity, especially on the cellular side. You're not dealing with those raw AT commands anymore. We have a really friendly API that lets you manage your cellular radio. Now, there are a lot of note card options. We just released a bunch new, so it gets a little complicated, but actually I think it provides a lot of value here. So all of these are fully swappable, and we start with the existing cellular-only note cards. These are a great option if you only need Cat1, LTE-M, or NB-IoT-based cellular. There's a new Wi-Fi only note card. It's based on the ESP32S3 module. We also have a new LoRa only note card and a new set of dual cellular to Wi-Fi note cards that allow for using either cell or Wi-Fi, or even a Wi-Fi to cellular automatic fallback option as well. And again, if you look at the bottom, they all have the same exact physical M.2 connector, and they all share the same developer APIs. Now, zooming in on the note card just a bit more, let me emphasize, it's a very much a low power system on module. It does have that M.2 connector at the bottom, as you can see. There are, again, cellular, Wi-Fi, LoRa options. The cellular one also includes a GPS module that you can use for location tracking. The cellular side of things, again, includes 500 megabytes of prepaid data, 10 years of global service. The note card also has an eSIM embedded SIM, but it supports dual SIMs. So if you happen to be in a country that the note card does not support by default, we support like 150 some odd countries, there is the option of being able to toggle between different SIMs. The API, the way you interact with the note card, is all JSON, and I'm going to let these guys explain more of that in a bit. But again, gone are the days of the archaic AT command syntax for managing your cellular modem. And we also have SDKs for a variety of popular languages and RTOSs. Obviously, Zephyr is a big one for us today. And on the note card side, again, we support popular cellular connectivity protocols. So again, I send everything with the note card is JSON or is a JSON-based API, right? So that means everything is JSON into the note card and JSON back out. As an example, if you want to get your note card's GPS location, you would call this request card.location with this syntax, and it will return the requested location. And the rest of the API is set up very similarly to this. But if you're asking yourself, like, JSON and C or Zephyr, doesn't that get kind of ugly? Well, our libraries help to abstract out that complexity. So you're making JSON requests and parsing JSON responses from the note card. Now, to make it easier to use your note card when you're prototyping or even when you're ready to deploy in a more permanent solution, we offer these carrier boards that are called note carriers. So these are development boards that let you snap in a note card and connect to virtually any solution you can dream up. I'll just run through them really quickly so you have a high level idea what's going on. The first is our F. That has a Feather compatible socket for obviously a Feather compatible host. The A model includes onboard antennas, which is really nice, and it exposes the pins, lets you hook it up to any host you want to. The B is a small form factor note carrier. These images are not to scale here. This one's actually quite tiny. The Pi, we actually released a new version of the Pi Hat, but it's a Raspberry Pi Hat. It slots into the 40-pin connector on top of any Raspberry Pi compatible single board computer. The new one has quick ports on the top as well, and it's got this gorgeous black PCB. Also, our friends at SparkFun released a Micromod cellular function board that fits in with their Micromod ecosystem. And finally, Rack Wireless, they just released Blues.1, which lets you use a note card in their WISP-block ecosystem. So lots of cool opportunities there. Now, I want to briefly cover another part of wireless harmonization, and that is harmonization of data flow. Again, sounds like a marketing gimmick, but it's legit. For us, that means you have the ability to choose your cloud and not lock you into a platform. So let me briefly introduce you to NoteHub, which again is the Blues cloud service that makes all this possible. So again, NoteHub is the Blues service that receives data as a proxy from the note card, and in turn will securely route it to your cloud application of choice. Within NoteHub, you can manage fleets of devices. You can update both microcontroller and note card firmware over the air. We have a relatively new feature called Note Card Outboard Firmware Update. This allows you to update host MCU firmware from the note card actually without requiring any kind of connection from, or a cooperation rather, from the host. It means you can literally switch host firmware from like CircuitPython to Arduino or whatever on the fly. It's pretty crazy. I recommend reading about it. And everything about the Note Hub is secure by default as well. When you're talking about the cellular access from Note Card to Note Hub, everything is off the public internet through private VPN tunnels, so it's an extremely secure device combination. Now, to help kind of visualize everything I just threw at you, I do want to walk you through a quick diagram here. So again, you're going to bring your microcontroller, your single board computer, your sensors, your RTOS, don't care what it is. Today it's Zephyr, which is awesome. You're going to compose packets of JSON data that we call notes. Now, these notes or these events are going to be queued. They're going to be stored on the note card. And then at a cadence you specify, you're going to securely, note card's going to securely sync those with Note Hub. Now, again, we don't want your data to live on Note Hub. That doesn't make sense for anybody. We want you to route that data out. So you can optimize, you can alter that JSON packet if you want to, optimize it for delivery to your cloud application. And it's important to note that communication with the note card is bidirectional. So you can start on your cloud app. You can send a JSON-based request to Note Hub using the APIs we provide. Note Hub will notice securely deliver that JSON payload to a note card, to a fleet of note cards, whatever it may be. And then the note card will deliver it back to the host. So you can easily handle like remote control scenarios or do remote fleet updates all remotely and all over cellular, Wi-Fi, or LoRa. Lastly, I want to reinforce this idea that Blues is always looking into the future. So our note card connectivity options share the same physical connector, same developer API. I already mentioned this once. This lets you swap out radio access technologies without code changes in the future. Pretty amazing. Also, when looking forward, I mean, 4G is going to sunset someday. You don't want to be caught in that sunset without a plan going forward. And Blues is thinking along these same lines when we talk about 5G and satellite and beyond. Nothing to announce today, but we've got our eyes keenly on the future here. And finally, when looking, looking forward, Blues isn't going to go out of business. But if we were to go out of business, you're not stuck. I want to reassure you that the 10 years of service you buy from Blues is still going to be available. Your note card will still function without Blues existing, which is pretty awesome. So before turning it over to TJ, last thing I want to mention about Blues and Zephyr are the Blues accelerators. So these are 50 purpose-built IoT apps that show off how to use the note card in a variety of practical solutions. Everything is free. Everything's open source. There's numerous Zephyr-based apps as well. And you can find all these at our developer site at blues.dev/accelerators. And I think that's the end of my boring slides. I want to get that out of the way. So I'm going to transition things over to TJ.
Cool.
I'm on mute. Yep. Didn't want to interrupt you, Rob. I hope it was all right for the viewers, but I think some of the slides with the animations were sometimes looking weird-ish. I mean, again, I didn't want to interrupt you because I think it was, in the end, it worked out okay. Hopefully people in the audience can confirm. TJ, I'm going to put your, screen on screen if you'd like. Yep, there you go. And hopefully you won't have the same issue with the screen sharing lagging behind. Quick reminder for people watching us: any questions, feel free to ask them. I haven't seen any so far, but yeah, looking forward to a cool demo of the thing in action.
Cool. Yeah. So I'm going to try to take what Rob showed sort of in the abstract on slides and show you them in action, show how Blues actually works. So what I have open is blues.dev, which is our developer center. It's kind of the place we recommend for any developer, any builder looking to get started with Blues tech. And the hardware I'm going to be using, I'll hold it up here so you can see it a little bit, is the contents of our Blues starter kit, which if you're curious about for trying any of this yourself, you can follow this link to get one of these kits yourself. But the starter kit has a note card. So the note card is this guy here in the middle. I have a cell plus Wi-Fi note card. So I have a note card that's capable of talking over to a network over cellular or Wi-Fi. I have the note card attached to a note carrier, which is this rectangular development board. This is the note carrier F, the F being for feather, because this is a development board that allows you to attach a feather compatible microcontroller. And you can attach any microcontroller you'd like in there, but I have the Blues Swan, which we include along with a Blues starter kit, just because it's our sort of opinionated way for getting started with a note card. Again, we try to let you mix and match, bring anything you'd like, but the starter kit is sort of our opinionated way. If you're looking to prototype, if you're looking to start fast, this is sort of our way of doing that. So I have my starter kit all set up and ready to go. I've also got it connected through USB, and that's going to matter when we start our tutorial, because what I'm going to do is go to this Get Started link, and then I'm going to go to the Note Card Quick Start, which is a tutorial we have that walks you through the basics of how the note card works and how to get up and running with it. And because I have that note card connected through USB, one really cool thing that you can do with the Blues note card is if you look in this panel that's appeared on the right-hand side of my screen, we leverage what's called the Web Serial API. It's a browser-based API that's built into Chromium-based browsers like Google Chrome. We can use that to connect to a note card over a serial USB connection. So by clicking those buttons, I've now connected and just basically made this connection to the note card and can issue commands over serial directly through the web browser. We like using this for testing, for prototyping, or even just for messing with things, even as I'm doing development, even nowadays, even though I know how the note card works. Once you've made this serial connection, this tutorial is going to walk you through the basics of what Blues is and how Blues works. It's going to show you how to take your hardware and connect everything together, basically how the puzzle pieces slot together. And then when you get down a little ways, and I'll pause here for a second, just making sure my screen is coming through all right. But the first request you'll want to run is this one here, this card.version request, which I'll go ahead and run and send to my device. Now, a couple things I'll point out. The first is the note cards API, as Rob mentioned in his slides, is JSON based, which means I send JSON in. In this case, I'm telling the note card I'm making a request named card.version. And then the note card returns JSON back and as a response. So in this case, card.version is very much just like the let me get metadata about the note card. So this is just going to return some basic information like firmware version, and it's going to tell me this note card has Wi-Fi, cellular, and GPS, different metadata like that. This is just, the first request is really intended to just show you the basics of how the API of the note card works. You can send these requests through the browser like I'm doing here, but you can also send these same requests through our CLI that we provide, and also through our firmware libraries. So for Arduino, for C, for Go, Python, and more importantly, you're going to see in a minute how you can also send all of these requests that I'm running through the browser in a Zephyr app here in a minute. But we're going to start with just the basics so you can see how the note card works in isolation. So that's card.version. That's pretty simple, though. It's not really doing anything useful. Chances are the reason you're looking to work with a note card is you're looking to do something with data. And when you want to start working with data with the note card, as a first step, you want to set up NoteHub. Now, NoteHub is our secure cloud backend, and you'll need to just create a free account on NoteHub and then create a project. So I've already created an account, and I'm going to create a project for this demo. And I'm just going to give this project a name of Zephyr and create it. A project in NoteHub is just basically a logical place to group your devices and your data and your configuration settings that come through. So I'm going to take this and grab this identifier from my new project. An identifier, which we call a product UID, is just basically a unique way of referring to the NoteHub project. And it's the way you link your physical note card to a NoteHub backend. So if I go back to this tutorial and I scroll down just a little bit, you'll see that the next command this tutorial is going to want me to run is this hub.set request. And when I run it, I'm going to take and replace the product I have here with the one that I just created in the browser. And I'm going to make that association between the physical note card here on my desk and that NoteHub cloud backend. Now, when you make changes to the note card by default, so if I go back here, my device hasn't magically been registered. The note card is set up to be a low power friendly device by default. which means the default behavior of the note card is to take any changes you make, like in this case, this association of a Note Hub project, and to actually queue those changes up on the device. And then to then sync those changes at an interval that you can configure. So you can either configure those intervals. There's ways that you can provide them to this hub.set request. You can say, I want to sync changes every hour, or every 2 hours, or every day, which you'd want to tweak depending on your battery situation. You can also say to put it in continuous. If you know you're getting mains power to your note card and you just don't want to wait for anything, you can also do that as well. So there's lots of different configuration options you can use. Or if you're running a demo like I'm doing today, there's also a hub.sync request, which basically just tells the note card immediately synchronize the data that you have queued up. So in this case, it's going to take the hub.set that I had here with this new product and sync them. Now, I did cheat a little bit and run one command before I started this demo, just to save us a little bit of time. You might have noticed real quickly up here that it said connecting to Wi-Fi. I did run a request called card.wifi, and you can see the reason I ran it before, because I clearly can't type anything. But the card.wifi request is a way of telling a Wi-Fi enabled note card which Wi-Fi network you would like to use. And in this case, it is connected to my phone. My phone's Wi-Fi there, which means that when it did this sync, which the sync just happened, I saw it just go through, this sync actually happened over Wi-Fi. So I've got some metadata in here, and I think if I, I got some metadata about my device that came through here. My device is now showing up on the back end. So in this case, this hub.set that ran, I've made the association over Wi-Fi between my device and the Note Hub Cloud backend that I set up. Now, once I've established that connection, I can now start using that sort of data pump, start sending data from my local device up to the cloud. And if I scroll down in the tutorial here a little bit, I can do that with the note.add command. So note.add is going to take an arbitrary JSON object. So in this case, we're going to pretend that we have temperature and humidity sensors that we're gathering from like a microcontroller. We're formatting that up into this note.add request, and we're sending them up to the cloud. You'll see that that happened pretty quickly since I have Wi-Fi enabled on this device. So if I go to the events of my project, you'll see that I have this data.qo file, and I have my data flowing through. So pretty simple. I queue up a note, and the data flows through up into the cloud. Now, what's cool is that because this is a cell plus Wi-Fi note card, one thing I can do is I can kill my hotspot. So I'm going to go ahead and turn this off so that I no longer have Wi-Fi connectivity. So you can think of this as pretend you're building a product that for the most part is communicating over Wi-Fi, but say that device is taken outside of Wi-Fi range, or somebody cuts the cord, the Ethernet cord, the router gets unplugged, whatever. And for whatever reason, the Wi-Fi is no longer available. And then suddenly you have some more data that you want to send. Let's just change these numbers so we can see the difference. Sure, the temperature is 356. Why not? We'll queue this up to the note card, and then we'll run another sync so that we can send this data up. You'll see that it's going to attempt to synchronize over Wi-Fi, but the note card is going to realize that this Wi-Fi network is not available because I've told it it's not there. It is going to take a second to try. It's going to do its due diligence to find this network, but then it's going to realize, you see the modem now on, because it has a cellular connection, because it has a cellular modem built in, it's now firing up the cellular modem. It's going to use that to send the data instead, and it's connecting over TLS and doing that. But the cool thing is, notice how nothing I did as part of this demo explicitly told the note card what to do with cell or Wi-Fi. I did have to tell it which Wi-Fi network to use, but I didn't have to tell it. I didn't have to do any checking of whether which network is available. The note card automatically handled all of that for me. So if I go back to my back end and the data to come through, you'll see the second note came through over cellular. I can also go into these session notes, because in here, if you're just curious, like which technology is being used to send these, whether it's cellular or Wi-Fi, you can go into, this is the original one. So I have this thing in my JSON that says the radio access technology used was Wi-Fi for this one. And then if I go up to my next session up here and go to the JSON, the radio access technology right there should be LTE. But again, hopefully you can see the power of what the note card makes available. So not only did I not have to care cell versus Wi-Fi, but when it came to cellular, I didn't have to interact with the cellular modem at all. All that was abstracted to me. I just got to work in this very simple syntax where I just got to basically queue up the data I want, set some interval for how often I want that data to synchronize, and let the note card completely take care of connectivity, both for Wi-Fi and for cellular. So that's the sort of basics of the note card. This is a little bit of a whirlwind tour, but hopefully that gives you a sense of what is possible. Now, I focused on showing these commands just directly through the browser, through Serial here. But as I mentioned, you can also send these commands through our SDKs. And so I'm going to use that as a transition to Zach here, because Zach's going to go into how Zephyr sort of plays into this and integrates this and how you can leverage all of this from your Zephyr-based apps. So Zach, you want to take it from there? And then I am going to bring you your antenna.
Thank you very much. Yeah, that sounds great. So we're going to do just what TJ said, and I'm going to start in a place that is familiar to everyone, and that, or well, everyone on this call, I should say, and that is the Zephyr Blinky app. So this is right where you expect it to be. We're under Zephyr project, Zephyr, I think samples, Blinky or Blink, whichever it is. And then you get into the source file, and here's your main. It's extraordinarily simple, but it works really good to illustrate how I can take an existing Zephyr application, one that I have already built, I know works and runs. And so to prove that, we'll just start doing the simple things. So I'll do a West build, as you all know. The board I'll specify as our Swan. That's the one that TJ just told you that comes with our dev kit. And then I'll just use Pristine always for this. So, you know, I don't know. I don't need to, but I think it just makes it cleaner. And we know that it's that me changing things gets always fully incorporated, because I'm going to go through and add in note card support. And I'm going to show you how easy that is. So we'll do it step by step. It's copy and paste. If it goes fast or you don't understand like a logical jump that I'm making, please ask questions or catch me after for questions, because I'm not going to take the rest of the hour to show you this because it's pretty quick. And I love answering questions. So, all right, here we go. So let's build it up. And this is your standard issue Blinky app from Zephyr. There is no blues in this. And then we will flash it over to the Swan device. That's done. And now I'm going to hold this up. Hopefully you guys can all see it. This is the Note Carrier F with the Swan on it. And you're going to see the Swan is blinking just like we expect from the application. So as far as anything to do with note card, that's not happening right now. We're just blinking, and it's just sat into the Note Carrier for power. All right. My lovely assistant, TJ, is plugging in my antenna now. So when we get to the note card stuff, you'll be able to see it. Okay, so here we go. So let's cruise over to GitHub. So what we've done is under our GitHub account, Blues, we've created note-zephyr as a repository. So this repository, actually, if you start picking through it, you're going to see that this is actually just the Zephyr Blink app with the extra things that are required to do Node Hub communication. So it's really simple and straightforward, and that it makes it really a one-to-one pairing with what I'm showing you right now. So this is a great resource to look back to. Thank you very much. This is a great resource to look back to after this talk, so you can kind of, if you want to go through it yourself or more slowly pick through the files. Okay, so let's start with the most obvious thing that we see here is Note-C. Note-C is our C library SDK that provides a whole set of APIs to facilitate the interaction with a note card. It's pretty simple to use. Let's see, I'll just bring it up here. What do we have? I mean,
you may want to make the font slightly larger as
well.
Yeah,
sorry about that. Yeah, let me get that
no worries.
handled. All right, there we go. Here we go. All right, sorry. There, is that better? Or do I need to go bigger still?
Yeah, no, perfect, I think. Yeah, thanks.
Okay. So there's not much to this. I don't want to hang out in source code land, but you'll see that what this has is basically a set of, yeah, we didn't write a lot about it, hooks and things so that you can plug in anything that you've got existing into, it's like a set of callbacks to get down to I²C. So it's a platform abstraction that sits underneath this. You provide the hooks, and then we'll call, let's see, we'll call it like the UART or I²C as necessary. And the whole thing works pretty slick. All right, so let's actually get to it. Let's see it in action. So I'm going to back up to, oops, I want to go to note. Oh, I'll just type it up. So back to note-zephyr, which is where we're trying to go. And I'll go over to my project, and I'm going to go ahead and clone note-c in there. So that's first step. I'm in Blinky, in the Blinky folder. I don't need to go to any special subfolder. And I'll just say git clone https github.com blues note-c. So we're going to bring note-c into this folder. You could do recursive. It doesn't matter because this is just one deep. Super small, super fast to come in. All right, now that's there. And now what we want to do is we want to provide a set of hooks so that we're able to bind what's in note-c into our note-zephyr application. So if we flip back over here to GitHub, we're going to go grab right here in the source. We have note-c hooks, C and H. So there's nothing to do here that's overly complex. We'll just go into the H file, select everything, and then I'll jump back in here. I'm going to add a new file, which will be note-c hooks.h, and then splat the code in, save it, make another new, another new file. Or let me try that again. Make another new file, note-c hooks.c, and then I'll jump back over to GitHub and grab that one, select everything, and I will get back in here, paste this in. So again, this is not anything that you have to think about. This is just add these so we have our callbacks. I've already written the callbacks for you. Just bring them into your project. So that's what this is. So now that work is done. Okay, so, and then I've got a little cheat sheet over here to remind me of what all I need to get done. All right, so then we'll go into the CMake, and we're going to add in the parts of the CMake so that it will know to pull in the note-c library we just added. So I'll hop back into here and the CMake list.txt. The only part, this group here. So this, yeah, we'll talk about it now that I've got it selected. So what I've done is I've added the note-c hooks along with main C to be compiled. That's pretty straightforward. These are the files that we care about in note-c that we're going to compile in. And then I added the library to be included. So there's nothing, no real, I don't know, no fancy stuff. It's just pretty straightforward. So I'll replace this with the one that, oops, I didn't copy correctly. Let's try that again. So I'll replace this bottom line of just compiling main C to be compiled. Okay, this is, I'm just going to grab it from here. Sorry about that. All right, let's try it again. Copy and paste should be pretty easy, and I'm not able to pull it off for some reason right now, which is driving me nuts. Why is that not working? Okay, this is not where I thought the demo was not going to work, to be honest. Let's see. There it is, finally. Good Lord. Okay, so there we go. So I replaced where it just compiled main.c, and now we'll compile the note-c hooks, like I had said, and note-c itself, and then include note-c into the application. One more thing that we need to do. Okay, and I did create these variables. This was up above on GitHub. It was right up here. But that'll need to happen as well. You have to tell it what note-c is since I'm referring to it right here below. All right, so CMake is done. And then now we go over to our PRJ config, or project config, whatever. And let's see what we did on GitHub. Hop back over. It's super simple. These things are just all the little things you have to enable so everything starts working. As you can see, the config GPIO is already there because that's what's turning the LED on and off. And we're going to add I2C communication so we can talk to the note card. We're going to add new lib in so we get our libc. And also we'll support printf debugging or through an ST link. That's what all these things do. All right, so I'll come here and I'll just add these to the bottom. That's complete. And back to the cheat sheet. So if I've updated PRJ config, I've updated the CMake. Okay, and now we'll update the main so that it comes in, and I believe that will be it. Yep. Okay, so let's have a look over here for the last bits. So let's go into the main that is already existing, the one that we got, the super simple blink. We know exactly what this does. It's got a delay. Here's your GPIO control. We're going to come in here, enable the GPIO so that we can turn it on and off, and then we're going to literally turn it on and off and then sleep and do this infinitely. That's the Blink app. We all know about it. We know how it works. And so now let's add in a little bit of logging to the note card so we know the status of our light. Not that this is important, but it gives you the idea that if you have your existing application, you add in the things that I just added to this project, then you can start sending diagnostics out over the web with just a few more simple commands. So if I go back to GitHub and then I go to main.c, I can start to see the difference. So just like TJ told us about, we need to have, well, here, I'll include note-c and the note-c hooks that I just created. And then also we needed to find a product UID. And this is what TJ was telling us about. This is how he set up a new project on the cloud and then brought it down here. I did the same thing, but mine's called webinar. I'll add that in just a second. And then I extended the sleep time to be 10 seconds because sending a new note every second is possible, but it's you're just constantly running the modem. So I gave us 10 seconds to have a little breathing room. All right, and so this is the first part that I'm going to add in. So let's jump over to the source, and I'll come, let's see, up here at the very top. I'll replace the sleep time because my new sleep time is 10 seconds instead of 1. I'll paste that in. All right, so now there's the new sleep time of 10 seconds. My product UID is going to be .com, was it blues zfields : webinar. And so now it's going to, whenever, this is what TJ was doing in the terminal, but now my firmware is just going to write it every single time. It does not need to write it every single time. It does not hurt to write it every single time that it boots. So I just let it go like this. And that way my note card, every time it restarts, it just re-updates the configuration, and this is no problem. So, all right, we'll save that and save that file. All right, and then the next thing we do after that is we're going to configure the note card with our callbacks. So we scroll down a little bit here, and you're going to see initialize the note-c hooks. So right here, we're setting a user agent so that we know that this is the note-zephyr project. This is stuff that we use at Blues to see that you're using note-zephyr. This helps us put more effort into this project. So leave this in if you don't mind. You don't need to have this at all. But if you have it, then you help us put energy back into this. This is kind of like filling out a census. If you know, so your country or your city can put more money towards your town because there's more people there. All right, and then the next things we do, we're going to put our memory allocator, malloc, our freeing memory, free hooks in here. The platform delay, this is one of the things I created in note-c hooks. And platform milliseconds, this is, again, one of the functions I created in the note-c hooks. You can go look at these on GitHub. I don't really want to walk through them. They're super simple. I'm just gathering milliseconds and waiting a certain amount of milliseconds and effectively using the Zephyr interface with more of an Arduino style API so that it binds more easily into note-c. The logging function is here. This is also in the hooks. And node I squared, or the I squared C reset, transmit, and receive functions also in the hooks. And so we're just going to grab all this stuff. So basically now this step binds our hooks into our firmware. So, and then if we look below, we see hub set. This is literally what TJ issued in the web terminal. So we're just going to construct a JSON object and then send that over to the note card. So I'm going to grab that as well. So now I've got my hooks and the source code required to create the JSON to configure the note card. All right, so we'll take that. We'll paste it. Let's see, I think I put it right after this. I'm almost positive it's right here. All right, so we'll add that here. So just another copy paste job. And then we'll jump back to GitHub. There's one more thing now, and that is literally just to log. So this is note add. This is where TJ set it to 365 degrees or 56 degrees or whatever. We're going to log the state of our LED. So we're going to see that it's either on or off. And that way we know what's happening inside of our application all the way up at Node Hub, which can be forwarded to our cloud or dashboards that we've created. All right, so we'll grab that. We'll hop back over here. And I believe I logged the state right after I set it. So there you go. All right, let's compile it and see if it goes. That's the next step. So West build. And let's see what I forgot. Nothing. I'm impressed with myself. I really thought it wouldn't work.
If it compile, it works, right?
That's unbelievable. All right, so we'll flash it over. Okay, so now I've got the Blink app. You'll see that this is no longer blinking at the frequency it was before, but it will start blinking because it's going to go for 10 seconds. So there it goes. It's going to be on now for 10 seconds. It'll go off again for 10 seconds. So that's happening. So we've updated the firmware. That part's all good. And then if this plays nice with us, we'll jump over here to Node Hub. And this is where I didn't have a device before. So it's going to, just like TJ showed, right now it's running through trying to do the first sync. And we should see it show up here. And this is, just like we saw before, this is the .com blue zfields webinar. And that's hopefully, I'm just going to paste this next to the source code while we're waiting. Make sure that I have that linked up correctly, because this would be a point of failure if I pointed it to the wrong place. That looks pretty good. So let's just paste it down here and push it over and see that they look nice. And I think they do. Yep. So feel good about that. And then, so it's really just to wait until it gets its first connection. I got a note card that was fresh out of the box. So it has to establish its first cellular connection, register with the network, and push through. I'm happy to take questions while this is happening. This is just a waiting game, and it's kind of boring to wait. So, but you can see, I guess, to summarize, what we did there was I have everything set up for you to review and look at. And all you need to do is you can take any existing application, whatever you've already built with Zephyr. It can be anything, add in a few simple components, and all of a sudden you have every type of wireless communication that Blues can offer you. It's super simple. We did it all here today in real time. So that's all the time it takes to take your application from something that's embedded to something that is IoT. It's awesome, and it's fast, and it's easy. And so hopefully, let's see if I refresh. Maybe we'll have something by now.
Yeah,
no?
Maybe we can take, and happy to maybe put Rob on screen if he wants to take the
Yeah,
question while you troubleshoot. We have a question from YouTube. How about the licensing? Like we spoke before about like vendor lock-in potentially, and like having 10 years of cellular time, etc. Question is about the licensing of the Note APIs and the PCB connectors. For example, would a third party be able to create a Note compatible card?
Yeah, it's a great question. And I guess to give some historical context for Blues, we've been a company for about 5 years now, and our secret sauce is really embedded into the note card firmware. So that is all proprietary. So you're not able to. So the firmware on the note card is not open source. You're not able to clone that and build your own, because the value we're trying to provide is to take all of those components that you're normally putting together to construct like a cellular connection and put it onto one board. If we're not providing that value, if you don't see that value when using Blues in the note card, then maybe we're not for you. But we think that we are simplifying wireless IoT of all types by introducing the note card and the different options between cellular, LoRa, and Wi-Fi. But I totally get it. Some people like to build everything on their own. They want to source their own modems. They want to write AT commands. Personally, for me, it's not for me. I'd rather focus on building out the rest of my firmware. Yeah, so it's my long-winded answer.
Yeah, no, thanks. How are we doing, Zach? You like?
Yeah. So what's happening with me over here? I think what happened is the note card, while I was talking, decided it was in the penalty box because it tried to sync without an antenna. TJ brought me the antenna, as I was hacking along there, and so I have it set up. Let's see. It's powering on the modem, and I think it's starting to so it went through trying to get into the hotel Wi-Fi, and now it's going through, powered up the cellular modem, just like we saw. I'm tracing it out right now using our terminal on our website, which is another, again, it's an awesome thing that we can do here. Okay, good. It just synced. It did the sync. And so now let's go over back to Node Hub and have a look. We should see it here. If I can refresh the screen, there it is. Yay. And so I've got my Zephyr Blink app. And then if I look at my events, what I'll see is my LED state was true, and then false, and then true, and then false, and then true, and then false, which you would expect. And so it all worked. And so what had happened is it put itself in the penalty box. That's actually a desirable thing, even though it's not desirable during a webinar, because this conserves battery. Oh, let me stop sharing my screen. It conserves battery. And that's like the important, one of the key features of the note card is it is built for battery powered devices. And so it'll put itself in a penalty box if it continues to fail to receive Wi-Fi over and over and over, or Wi-Fi or cellular over and over and over again, so that it doesn't, using cellular power is what burns all of the energy that you would have stored in your battery to do a sync. So it's actually a big deal that it does this behavior, but I had to tell it to leave the penalty box by manually requesting that it does a synchronization with Note Hub. And then as soon as it did, it checked Wi-Fi, just like TJ's did, decided Wi-Fi is not available, and then flipped over to cellular and went up. So
great.
Yeah.
So there is one question from the audience, but maybe one from me first. So you mentioned that putting the user agent would help you guys with like prioritizing and having more effort put on Zephyr in the future. One thing that, like as you were going through the demo, one thing that I was wondering if are there plans to maybe turn the like all the wrapping that you did in the note-zephyr project, turn that into an actual Zephyr module so that people can sort of directly pull the like most of the bits without having to necessarily mess up with the like the CMake, etc. manually. Like, is this a plan, or if not, like, do you like would people like be able to make pull requests maybe against the project or things like that?
Yes, absolutely. To both of those things, that is on the radar. Again, time is hard to allocate, and so yeah, that's why we'd love to see. What you saw today was easy, and that's why. And so we put it up to show how easy it is to connect everything, and it was easy for us to create as well. So that way we can get something out there. We make it easy to connect, but I would love to make it easier. Yes, a module would be fantastic. We'd like to see some adoption. We would like to see, so guys, use this, consume the deal, and show us the note-zephyr come through our metrics. And absolutely. And I've wanted to do it ever since I went to the Embedded World in Nuremberg. Actually, got really excited about it there. I just have not had the ability to sit down and write it. So, and A group has built something like that, and we totally accept pull requests and awesome ideas. And if, we'd love to work with you if you're interested. We have IRTOS. I think that's the name. I hope I'm pronouncing it correctly. I know the letters, but they built a module for the note card. But we did a bit of a rev in the SDK. And so it needs to follow along with that change.
Right.
And so,
yeah. Okay, cool. Question from Christopher. Any future plans for Arduino style shield adapters? I think you mentioned Feather, but I guess Christopher means like the actual sort of historical Arduino footprint.
Yeah, I don't think that we have anything for the Arduino, the standard Arduino shield, but I mean, you may have noticed that this has a couple rails on it, and it kind of gives that Arduino style appearance. We built one thing internally and decided that it makes it hard to access the note card and does a few other things, but it's really nice when those rails are there, because if you're using protoboard or pegboard, you can create your own shield, and that works quite nicely. I do it frequently when I'm building stuff. So we like the idea, but I think Arduino, we have some Arduino stuff in the works, but it's not to do with the shield stuff. And I think now that they've got the R4 out, that kind of breathed some fresh air into the shield. But before that, the R3 was extremely old, and they'd seemed to have moved on to smaller 2 rails, and it was hard to tell what Arduino was doing. So we are in active talks with Arduino, and there's exciting stuff to come, but nothing we could announce today. But yeah, that's
and R4 is the Uno R4 as of last week is actually supported upstream in Zephyr. So there's that. Maybe it might be the last question that we are able to take. This one is about connecting simple sensor nodes to the note card is not very practical. Could the nodes communicate with a note card using, say, Bluetooth? And like that, many nodes could communicate with one node.
The way that I've handled this so far is to use, Zephyr's got awesome Bluetooth, as I think probably everybody here knows. But you can take a Nordic chip and put Zephyr on it and use the Bluetooth SDK. And just grab one of the Feather NRF compatible deals, you can push that into our Note Carrier F. It will talk right to the note card over I2C, which is all built together. And then you have your host microcontroller, that's the Nordic chip, reach out and talk to all of your Bluetooth peripherals. And I'm actually finalizing one of our Nifty 50 that Rob had talked about, those accelerator projects that demonstrates that. So
great. And you know what? I'm going to put everyone back on screen with the few minutes we have left. Maybe we can take the last question. And I don't know who if you want to take care of this one. Where do you see Blues used in the industry, or foresee where it could be used? And what is the economy of scale for the products? You have 30 seconds.
Yeah, the beauty and the horror of Blues is that we work everywhere with everything. So it's hard for our marketing team, right? When you're valuable everywhere. You can't really focus. But I will say that one of our largest customers puts a note card in every single commercial refrigeration unit they ship out, because they want to report on things like how many times is the door opening, what's the humidity, what's the temperature, which they can then use later on for like warranty management services. We've got another customer who drops a note card into curing cement to report the cure rate inside of cement as it's drying. I mean, so it's like,
and it stays there, like it's when it's dry, it's stuck there, or
right. So it's like a one-time use.
Well,
which,
that's
interesting. But yeah, there's all sorts of different use cases. It's really kind of fascinating to see what people do, stuff we would never dream up.
Great. Well, perfect. So we have people saying thank you, and thank you from my side as well for the great presentation. This is recorded. If you're watching us on YouTube, LinkedIn, please comment, like, subscribe. Like, we will make sure that any questions that you have, even if you're watching the recording, we get Zach, TJ, and Rob to help answer them. With that, we will be back in 2 weeks' time. I don't think we have the the talk actually scheduled just yet. I might be the speaker, speaking about my infamous artificial nose and how I recently ported it to Zephyr. If you don't know what I'm talking about, like pay attention to the upcoming event. It should be fun, like talking about TinyML and lots of cool stuff. Thanks guys for joining us. People watching, I put the link. If you're interested in submitting a talk, please do. We are probably looking at early next year because we have speakers lined up all until the holiday break, basically. Thanks everyone for watching, and see you in 2 weeks. Bye.
See everybody.